Hello everyone, welcome to Geeks for Geeks. So let's talk about today's problem. Our problem name is shortest path in undirected graph. Okay, so let's read the question first. Our question said you are given an undirected graph having unit weights of the edge, right? We have to find the shortest path from source to all the vertices, and if it's not reachable from that particular vertices, you just have to return a -1 in that case, right? Okay, so in the example part, if you see, we are given the n equals to 9, which is the number of vertices we have, and m equals to 10, which is number of edges you have, right? And we are given the vector of vector in terms of edge, right? And we have source given from where you have to start, right? And if you see the output part, so from source to every vertices, we just have to calculate the shortest path, and that's all the thing will be stored in your vector, and at the end of it you just have to return that part, right? That's a simple tasks to complete, right? So let's see how we can solve this problem. Okay, so as we see in the problem, we are given the vector of vector. So our first thing is, which we have to do is, let's convert that particular vector of vector edge into your array list, right? I already convert that part, right? As it's a unidirectional undirected graph, we just have to convert like this, right? So yeah, I hope you know that. Okay, so how we can solve this problem? So to solve this problem, a simple algorithm is helpful to solve this. So that is your BFS, right? Breadth first search. Using this, we can able to solve this problem, right? So if you are not able to know, if you are not able to do that part, so I just request, please first visit a video where you can understand that part, breadth first search, right? So yeah, now how we can solve this problem? So we know that in breadth first search, we use the queue, right? And we use the visited array, right? Where we mark that particular vertices as visited or not, it's coming first time or not, right? That's the main idea of using that part, right? Now see, we are given this source, right? This is the source, and we just have to calculate our smallest distance from this source, right? So what I'm doing is, let's create queue first. Okay, and this is my queue, and suppose this is my visited array, right? Okay, and the additional thing which you have to use is your answer array, right? Where we have to store my shortest distance, right? So all are of same size, that is your number of nodes you have or vertices you have. So let's create here. Okay, so visited will be this, and your answer array will be look like this. Okay, now see, what we have to do is, why we are using here BFS. For example, here we are right now at the source. Now see here, distance will be common, right? Which is 1. Now the thing which is very close to it, right? 0 adjacency node will be 1 and 3. Can you say that 1 and 3 are very close to your source? Can you say that yes, it's very close, right? Now when you see, your 1 will be at distance 1 from your source, this is also at distance 1, right? Now in my queue, we have to add that particular nodes which is very close to your source, right? And that's why we are using here BF. Now if you see, 1 is in my BFS, right? In my queue. Now 2 is very close to 1. So what we have to do is, we just have to ask 2. Okay, so the distance between 1 and 2 is 1, right? And can you please tell me, 1, what is the distance, your distance from the source? Okay, they tell, okay, let me check. My distance will be 1 from the source, right? And what's the distance from 2 to 1 will be 1, we know that. And tell me, what's the distance between 2, what is the distance from your source, right? They said 1. So that's why we just have to write here 2, right? That's the simple intuition, right? So which is very close to your source, we just have to put that particular thing in my queue, right? And we use the visited, so that we can mark that particular node is already visited. Please do not visit that particular thing again, right? Because it's a undirected graph, right? Okay, that's the thing, right? So let's do the dry run so that we can understand that problem better, right? Intuition better. Okay, so the first thing is, your source will be, let me clear this. Now see, step by step, right, how we can solve this. So your source will be this, right? So what can I say, that that particular source, from source to source, is 0 na? That particular source is already at that place. So can I say that 0 will be 0, right? Because 0 is the source. 0 to 0, your distance will be 0. Okay, so which is already calculated, can be marked as 2, right? So here rest all are false, right? If I am not marking that particular thing, treat it as false. Okay. Now what we have to do is always start from the root, right? Whatever the source we have, we just put that particular into my queue, right? So no need to mark this like. Okay, so let me erase this so that we can save the space. Okay, a little bit mistake here as well. 5 7 8. Okay, now see, this is my first element, right, in the queue. So what we have to do is let's pop this, right? And what we do in the your BFS, same steps we have to follow here. Okay, let's pop this and traverse its adjacency elements. So its adjacency element is 1, right? So when we go into the 1, we just have to ask, okay, 1 is false, they said yes. So what we have to do is we just have to put that particular in my queue, right? Let's add into queue and mark that particular as true, right? And when that particular thing is in my queue, what we have to do is I'm asking, so that particular distance is 1, right? And I'm asking to my this value, right, where I am traversing right now. Okay, so for example, this value will be val. Let me write here val. Now I am asking, hey val, can you please tell me what's your distance from source? Okay, they said okay, let me check in my answer array. They said 0. So 0 plus 1 will be the shortest distance, right? Like that we have to add here. Okay, after that, what's your another part? They said 3. So let me add, ask, it's true false, let's add into my queue, right? After that, what we have to do is I just have to ask from my answer of 3, can you please tell me 1 plus what's the distance from the val said I'm on source, so that's why what my answer here is, it's 1, right? Like that. Okay, after that, your this will be traversed. Now we just have to move to this one. Okay, so right now my val will be at 1. Again we have to ask, okay, 0 is traversed or not? They said it's true, it means it's already visited, right? That's why we just write the visited part. After that, 2 is visited or not? They said no, it's not. So let's visited this and put that particular into my queue, right? Now when we are at 2, what we have to do is we just ask from my val is 1, hey, can you please tell me what's the distance for your from the source? They said okay, let me ask my answer array. So they said 1, right? So 1 plus 1 is the distance between these two values. The distance between 1 and 2 is 1. Now I'm asking to 1, can you please tell me? They said okay, let me ask in my array. They said 1, so that's why 1 plus 1 is 2. That's why its output is 2, right? Okay, so that's a simple intuition. Okay, after that we just put here 2. Okay, like that we have to do that. Okay, after that, what's my val, right? So val will be 3. Let's go for the 3, and 0 is already traversed, right? After that we have to 4 is not visited. Let's mark true. After that, just put that 4 into your queue, right? After that, I'm asking, okay, 4, I'm asking to 4, 1 is the distance between 3 and 4, and what's the distance between 3 from source? They said 1. So 1 plus 1 will be the 2. That's why we just have to put here 2, right? You can also check here from distance from source, right, which is one step like that. Okay, after that, we are at 2, right? So we are pointing at 2 and 1 is already visited, right? My visited array will tell me. After that we are 6, right? So let's mark true and add 6 into it. Now I'm asking to my val is 2, right? So 2 will tell me what's the distance. It's 2. 2 plus 1 is 3. Let's add 3 here, right? Like that. After that, your 4 will be here. So let's mark the 4. 4 tell 3. 3 is already visited, right? And 5 is not. So let me put here 5 and mark 5 as true, right? After that, we just have to ask from my val is 4. 4 tell me, okay, it's 2. 2 plus 1 is 3. So let's write here 3, right? Okay. After that, we have 6. So let's cross this and go to the 6th part, right? And 6 tell, okay, 5 is visited. Okay. 2 is visited, yes. 7 is visited, they said no. Okay, let's do that. So put 7 here and mark true, right? And after that, what we have to do is we just have to ask from my val, which is 6. So 6 ka distance will be 3 plus 1, which is 4. Let's write here 4, right? After that, we have 8. 8 is not visited. Let's add here 8 and mark this is true. And the distance between 6 will be, okay, it's 3. 3 plus 1, which is 4. That's my answer, right? After that, we have 5. Let's cross this and my val is 5. 4 is visited, yes. 6 is visited, yes. Okay, after that, we cross the 7 and go to the 7. 6 is true, 8 is true, right? No need to traverse that part, right? Because it's already wasted. So 8, if you see 7 is okay, okay, it's true. 6 is true, right? Like this. Now at the end of it, my answer will be in my answer array, and we just have to return that. That's the intention, right? So if you know the BFS, it's very simple. We just add one step, that is your answer vector, right? Where we have to store my answer, right? Like this. So let's code this now. So the first step is, let's make the array list, right? And this is my adjacency list of size n, whatever the size of your n is, right? After that, I simply traverse the number of edges we have, right? And in that case, I simply mark the u, which is edges of first, right? And v will be edges of first, right? And ask here adj of u dot pushback will be v, and adj of v dot pushback is u, right? Like this we make it. Okay, so that's the first step. After that, we know that what we have to make is q, right? And q we make here, and visited array we have to make, right? Visited array we make, the size will be n, right? And mark all the elements as false, right? Okay, after that, we have to make the answer vector, right? And the size will be n, and mark as -1 right now. Okay, okay. After that, the first step is, we know that source will be given to me, right? So what I'm doing is, I simply push source into it, okay, whatever the source we are given in the question, right? And let's mark that particular thing as true, because the source is already in my queue, right? And the answer from source to source will be 0, right? That's the 3 steps we have to follow, right? After that, let's do the while loop, right? Whatever we are doing in the BFS solution, right? And the first step is, the very first value will be your val, right? And we just have to access using v dot print, right? After that, we just have to pop it. Okay, now we are at 0, just assume like that, and we have 1 and 3 as the corresponding elements adjacent. So how we can access? We just have to write the for loop, and here we just have to write the val. I want the adjacency element of val, right? So access pointing to 1. Now first step, we just have to ask, is that particular value is false? Okay, if it's false, it means that particular thing will be coming first time. Okay, what we have to do is mark that particular x is true. After that, put that particular into your queue, right? Okay, after that, your answer of that particular x equals to 1 plus whatever the distance of that particular val from the source, right? That's the simple step. So these are the steps which we are following in my dry run, right? Like this, we can complete our code, and at the end we just have to return the answer, right? Because at the end of the day, we just want a distance between that particular nodes from the source. Okay, so let's compile and check it's working fine or not. Yeah, the compilation is good. Let's submit and check. Okay, as you see, all the cases are passed, right? Our solution is submitted. Okay, now let's talk about its time complexity. So simple time complexity will be this part. It's order of m, number of your edges, right? After that, you know that we have edges plus we have the nodes, right? So in that particular case, it is undirected graph. Can we say that its complexity will be order of v plus c, right? Number of vertices and number of edges. In this case, can we say that it's order of n plus m, because n and m will be given to you, right? So whatever the complexity of BFS, here also the same, right? That's it. I hope you understand the solution and intuition. Thank you so much.